For this video, we will answer two problems. The first problem is a fuel furnishes 7,000 calories of heat per gram. Calculate the maximum work obtained from this heat in an engine which operates with water between its boiling point and 40 degrees Celsius. Determine the thermal efficiency. Ayan. Okay, so ano yung working equation natin? Oops. Yan ang working equation natin. So, by the way, when we say itong value na to, 7,000 calories, we can call it energy value, heating value, or calorific value. Pag sinabi natin HHV, higher heating value, yung water na product, it yung water would come out as a liquid. So, it means mas malaki siya kasi it includes the energy for condensation of water. How about lower heating value? Yung water is a vapor. Therefore, mas mababa siya kasi hindi kasama yung energy in the condensation of water. Parang additional info lang. So, we use the working formula na 1 minus Tc over Th equal to work max over QH. Sige. So, ano yung mga given sa atin? Alam natin yung mga temperature ng TCTH. Alam natin yan. And then, given din tong QH kasi, diba, yung fuel daw, ito yung energy value niya. Yan, 7,000. So, assume natin na meron siyang reactor, ginamit mo yung fuel, yan yung ilalabas ng fuel na energy, 7,000 calories. Yan. Pero, not necessarily na talagang nailalabas talaga yan lahat. In this hypothetical scenario, assume lang natin na nalabas talaga yung 7,000. Yan na yung QH natin. Okay? But of course, hindi kasi laging yung reactor adiabatic, tsaka hindi laging yung reaction, yung combustion reaction, mailalabas niya talaga fully yung 7,000 na calories. Minsan may unreacted fuel, yun. Pero in the hypothetical scenario, assume natin na malalabas lahat yung calorific value, heating value ng fuel. Rearranging the equation so that nasa kabilang isolated lang yung W max, so transpose lang doon. So, substitute na natin. 40 degrees Celsius. Diba? Tapos, boiling point. Working fluid kasi natin is water. So, boiling point times QH. So, therefore, yung work max na mapoproduce ay 1,125. Yeah. Next problem. An inventor claims to have developed an engine that takes in 25,000 joules per second at a temperature of 400 Kelvin, rejects 12,000 joules per second at a temperature of 200 Kelvin, and delivers 15 kilowatt of mechanical power. Would you advise investing money to put this engine on the market? Basically, ang goal natin is to check if feasible, possible ba yung claim niya. Okay, so mag-drawing tayo. Drawing natin yung claim niya. Okay? Hot reserva daw, 400 Kelvin. Cold reserva given, 200 Kelvin. Tapos, ang ina-absorb ay yung QH, 25,000 joules per second. Yung QC ay 12,000 joules per second. Tapos, meron kang 15 kilowatts. Ang kilowatts ay joules per second din. Okay? Tapos, kilowatts pala ay kilojoules per second. Yung double, so, yung gamitin lang natin yung equation kanina na 1 minus, 1 minus QC over QH. Okay. So, by the way, ito negative yan kasi palabas na siya ng engine. Ito negative din. QC over QH times, ano yung multiply? Work max times QH. Okay? Teka, pero gamitin natin yung TC. Tama. TC over TH. Okay. Hindi kailangan ng ano. Okay, ulit. Hindi kailangan ng absolute value sign. Over QH. Ayan yung gamitin natin working equation. Ito. Tinanspose ko lang yung QH sa kabilang side. So, 1 minus 200 over 400 times 25 kilowatts equal yan sa 12.5 kilowatts. So, dito pa lang, makikita mo na less than yan nung claim niya na 15 kilowatts. Diba? Less than yan. Kasi 1 minus 200 0.5 times 25. So, hindi. Ang claim niya is 15 kilowatts eh. Kita. Kaya, hindi tayo dapat mag-invest sa kanya. Yung isa pa, kahit gamitin natin yung isang equation na work max. Nakukuha mo dyan ay 13. So, less than pa rin ng 15. Okay, so maling-mali. Hindi talaga tama yung claim niya. Tapos, kung sasolve naman natin yung efficiency, oops, 0.5. Okay. 0.5. Sa Carno, yan na yung pinakamataas. Sa reality, hindi siya, we can only approach that. Pero, di ba sa reality ay up to 40% pa lang. So, hindi talaga. 3 times natin na-debunk yung, yung claim niya. Okay.